Hello again, geometry class, and here we are again with chapter 1, but we're in section 6 and we're going to be classifying polygons. Here's our objective. We're going to classify polygons based on their sides and their angles. So here we go. Alright, geometry class, here we are again, and we are in chapter 1, section 6, and we're going to be classifying polygons. And our objective today is to classify polygons based on their sides and their angles. So here we go. First, we need to know what is a polygon. And here are some definitions. A figure that lies in a plane, so two-dimensional space, is called a plane figure. A polygon is a closed plane figure with the following properties. It is formed by 3 or more line segments called sides. Each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. Now, we will learn about the parts of polygons and about ways to classify polygons in the next few slides. Alright, parts of a polygon. Each segment that forms a polygon is a side of a polygon. So here we have sides. Sides AE, ED, DC, CB, and BC. Those are all the sides of this polygon. The common endpoint of 2 sides is a vertex of a polygon. So here we have a vertex. That's where 2 sides come together. Here we have another vertex, another, and another. And if you notice in polygons, the number of sides that we have is the same number of vertices we have. A line segment, or a segment that connects any 2 non-consecutive vertices, is a diagonal. Okay, so as long as the 2 vertices aren't connected together to form a side, that is known as a diagonal. So like BD, that is the diagonal. I'm going to draw in some more for you. Here is EB. Here's another diagonal. AD. And then there's one more. CE. Those are all my diagonals in this polygon. And it will come in handy to draw some diagonals to figure out some more terms in the polygons that we are going to name. Okay, naming polygons according to the number of sides they have. Here's a list right here, and I encourage you very much to learn this list of names because it's not only useful in this chapter, but on many other chapters that we're going to be learning in this geometry class. So we have 3 sides. We should know that. That's a triangle. 4 sides. It's a quadrilateral. I know there's many quadrilaterals out there, and we'll study those later on. But we're not going to call 4-sided polygon a square or a rectangle or a rhombus or something like that. For this section right here, we're just going to call it a quadrilateral. 5-sided pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, and there's not an 11-sided polygon that has a name to it anyway. We'll just call it like this right here, n-gon. We'll call it 11-gon. Then 12 dodecagon. And then anything after 12, just like 11, we'll call it 13-gon, 14-gon, 15-gon, and so on. Okay, in this example, we're going to be identifying some polygons. We're going to tell whether the figure is a polygon according to the definition we had and its points that it had about the polygons. And if it is a polygon, name it by the number of sides it has. So here, part A, we have a figure and it is made up of all line segments and it is closed. So we are going to say this is a polygon, and since it is a polygon, let's number the sides here to figure out how many sides it has. Okay, so 6-sided. This is a hexagon. Now B, these are not line segments that this figure is being made up of. They are curves, and so since it's made up of curves, does not fit the definition of a polygon, so not a polygon. Alright, part C here, you can see that it is open. It is not a closed plane figure. So we again are going to say not a polygon. Part D, we have a closed plane figure and it is made up of all segments, no curves in this one. So it is a polygon, and we're going to number the sides again to count how many we got. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9-sided, that means it's a nonagon. And you'll have some more examples just like these in your homework, so pay attention to this. Alright, last example here, part E. I can tell you right off bat that since this side right here is not a line segment, it's a curve again, or an arc, we can call it. It is not a polygon. Oops. Okay, so that's it for this example. Let's move on. Here are some terms. All the sides are congruent in an equilateral polygon. So what makes an equilateral polygon is all sides are congruent. What makes an equal angular polygon is all angles are congruent. And a polygon is called a regular polygon if it is both equal angular and equilateral. And then if it is not both, if it's maybe one or the other or neither equal angular or equilateral, it is called an irregular polygon. Okay. Here are some more terms. This is about concave and convex. A polygon is concave if any part of a diagonal contains points in the exterior of the polygon. Okay, so look down here at this figure. This is how I'm going to explain it, what this definition means. Okay, so whenever we were talking about diagonals, I said we're going to connect two vertices together that are not consecutive, meaning lie on the same line, like this and this. These two are consecutive, but these two are not. And when we connect the two of them, well, that diagonal lies on the outside of the polygon. So this means it is concave. And let's see, a convex. If no diagonals contain points in the exterior, then the polygon is concave. Another way you can say this, all the diagonals are on the interior of the polygon. So just like this figure right here. A nice little hint right here, a regular polygon is always convex. I say this is a hint because the next example you will see some polygons, and we're going to ask to find whether it's concave or convex, and that is a really nice statement there. A regular polygon is always convex. so tell whether polygon is regular or irregular, and then tell whether it is concave or convex. So first, let's look at part A. We can see that all sides with these tick marks are being said that they are congruent. Well, these two angles are congruent. These two angles are congruent, but they're not all congruent to each other. So it's equilateral, but it's not equal angular. Therefore, it is irregular. But this is a polygon that has all of the diagonals on the interior. So it is a convex polygon. Now this next one, we can see pretty plainly that not all the sides are congruent to each other. But let's look at the angles. We see mainly right angles being stated here. But what about this angle here? That is an interior angle right there. That is not a right angle. And for a polygon to be equal angular, all the interior angles have to be congruent to each other. So this is neither equal angular or equilateral. So therefore, it is definitely not regular. It is irregular. Now, since it is irregular, I'm going to state that, no, we can't say it's irregular in convex or concave. It's regular. If it's regular, then it's definitely convex, but not the other way around. So look at the diagonals. The diagonals that we can connect here and here lie on the outside. So do these right here, here, and here. So those diagonals all lie on the outside, making this concave. Alright, this next one, part C, we can see by these tick marks that all the segments creating this polygon are equal, or are congruent. And then same goes with the angles. All the angle markings means that these angles are congruent. So equilateral and equal angular, this one is. Therefore, it is regular. Regular. And if it's regular, then it is convex. Alright, this last one here, these tick marks mean these two sides are congruent, and then these mean those two sides are congruent. But these two are not, these two are not. Therefore, again, it's irregular. And then if we connect these two vertices, again, a diagonal lies on the outside of the polygon, so it is concave. And that is it for this lesson, and I will see you in class. We will work on our homework and any other questions you may have about this. I'll see you in class. Bye.